Good evening, everyone. Welcome to the second day of the FDP, AI Agents in Action. On behalf of Computer Science Engineering, KKR and KSR Institute of Technology and Sciences, a warm welcome to you all for the second day of FDP. Today, our featured speaker is VARDHAN garu. He is a research intern at IIIT Hyderabad, and he is an AI and ML educator and researcher at TechnoFeature India TFI. He is AI and machine learning specialist, and he is experienced in designing and deploying intelligent systems spanning large-scale generative models and resource-constrained environments with a strong focus on reliability and scalability. He has a very good technical expertise, and he is certified in Meta-Prompt Engineering and MongoDB. He also specializes in architecting generative AI applications, prompt systems, and data workflows for efficient real-world deployment. He is an academic and research orientation and also engaged in applied AI research, model optimization, and AI hardware integration, with an emphasis on reproducibility, system efficiency, and structured knowledge transfer. He is a very vast profile, and he is a very young person, and we are delighted to have you in the day too, sir.
Ma'am, thank you for your introduction. So, if it's everyone, will just start the session.
Yeah, sir. I hope
Fine.
everyone is ready. Shall we start the session? Thank you, everyone. I am handing over the session to Harsha, sir. Sir, please.
Yeah, ma'am. So, good evening, everyone. As you guys just know, that my name is Harsha, and I'll be dealing with the second day of the FDP. I'm very happy that I'm able to join with you guys and take the session. So, as per the day 2 agenda, we'll be dealing with how AI agents make decisions. So we have dealt with in the yesterday session, you guys have we have dealt with something called as a difference between an agent and a bot. So today our session would be a bit oriented towards how agents work or how do agents actually think. So a decision making is a process that also involves thinking. So we'll just see how those agents think in today's session. I hope I'm just audible to everyone and everyone is clear about the agenda or about the things that we'll be talking today. Yeah. So if my screen is visible to you people.
Yes, sir.
Yes.
Yeah. I guess we're good to go. So firstly, how AI agents make decisions. So in order to know this, we'll have to understand how the inside engineering of an AI agent works. Yeah. So our module 1 of the session would will be talking about AI agents, the core of agents, and what are the types of agents or what are the types of decisions that agents will be taking. And in the second, we have something called as decision modules. So what are the modules that decide whether an AI should go to the right or should go to the left? So these are the models or modules that actually decide the core logic of an agent. So we'll be dealing how they take those decisions. And the third module is reinforcement learning. So we all know what reinforcement learning is. We'll just get to know how these agents use reinforcement learning. So we'll just get into firstly, what is decision making in AI? Yeah. So we'll talk about decision making. So let us just consider our AI agent. Let us just consider our AI agent as something called as a compass. which does not know where things are, but it definitely knows where to go. So a compass does not know where it is. It does not know the location it is in. It does not know where it is pointing towards. All it knows is now north, south, east, and west. So our AI is something similar to it. And that agent decides whether to go north or to go south, depending on its depending on its surroundings or depending on its decisions. So when it comes to decision making, the process of choosing actions is option based, and options are only information based again. So for example, let's say there's this 12-year-old boy who does not know anything about the whole world. He does not perceive things in the way that we do. He does not know much about life. But yeah, he learns from his mistakes. Yep. So he has multiple options to choose from. So our agent is similar to it. And the key characteristics are, firstly, it has multiple options to choose from, which is the actions that it can perform. Let's say I ask an agent to make a research paper for me. I asked the agent to make a research paper for me. I'm sorry that my PPT is just scrolling down. Give me a minute, I'll just fix it. Yeah. Yeah. So, mm, yeah, where were we? We were at this point. Yeah. We were at the decision making core part. Yeah. So it has multiple options to choose from, which means whenever I say an agent to do this certain task of finding a research paper for me, it could either go to something called as a web search, a web search where it just searches for the topic that I have asked a question in. Let's say I've asked a question saying, I need a research paper for AIML based reinforcement learning, or I need a research paper to write novels on it. So it has multiple options. Multiple options like what? It could choose from Google Scholar, it could choose from ResearchGate, or it could just sum up everything. It could just sum up everything like all the answers that each and every source gives it and then give it to us. It could do that. It has multiple options and multiple ways to choose from. And the way it chooses, or the decisions it takes are purely information based. So by information, I again mean the input that we will be giving. The input that the user will be giving would be the information. So that information, we call it as knowledge or state of knowledge. So that state of knowledge is all what that agent would be having in the first sense. It only be having that knowledge, and based on that knowledge or information, it will just try to choose the best option out of it. Next, goal oriented. Our agents are always goal oriented, or their decisions are always goal oriented. But when I say you need to search a research paper for me, it does. My agent does not go somewhere and search for some story. It only searches for something called as research paper. It knows its goal, where to go and how to go. So all the actions that it is taking are specific and they stick to the objectives or the core reasons why they are doing it. So that is why we call our agents goal oriented. And yeah, adaptive. So the fourth point is adaptive. So we all know that each and every AI agent out there adapts to the user or adapts to the type of prompts or type of things, inputs that we give. And what do you think that this adaptive over here just says? It says that all the agents are different. Their programming languages are different. And depending on the input, they can adapt to what sort of thing they'll be searching for or what sort of research they'll be doing. Depending on the input, it will just adapt to the method that it is supposed to. I hope we are just clear with this thing. We are clear with this slide, I guess. What is decision making in AI? AI chooses out of all these characteristics that I've just explained. It has multiple options, and the actions that it takes are purely information based or the input based, and then they are goal oriented, which means they only take actions based on the end goal, and they are adaptive. So our next point of discussion would be yeah. So our next point of discussion would be why decision making matters. So why is decision making a thing that we are supposed to talk? So what makes us sane humans from insane humans? So a difference between sane humans and insane humans is simple. Sane humans take decisions that don't harm their life. Sane humans take decisions that don't really harm their life or don't really make their life harder than it is right now. So any decision that we take would help us, not put us in some problems. So that is why decision making in humans matters. But when it comes to AI agents, decision making is the heart of intelligence. So decision making is what separates reactive systems from truly intelligent agents. So when I say reactive systems, I'm talking about ChatGPT or any chatbot out there. It only reacts to something called as a prompt. Whenever we give an input prompt, it takes that input and based on that input, it will just give you answer. But it does not act on intelligence. So all the inputs that a chatbot or any GPT out there would give you would be based on the training data or the knowledge base that it has. It does not think out of that box. So why are intelligent agents different from it? We just talked about it yesterday. What is the difference between a bot and an agent? So when it comes to the decision making matters, it uses core of its intelligence, the core or the logic part, where we call that agent intelligent. Why we call it intelligent? Because it makes decisions that matter. And next, enables adaption. So adaption is a case where each and every time I go to a single agent, let's say I have some research topic of topic X and I get the output. Next time, whenever I ask the agent about a question regarding another Y topic, it does not stick to the retrieval part or it does not stick to the method that it used for the X topic. So it makes its own decisions or it makes its own logic for the Y part. So in each scenario, our agent adapts for the input. So it really adjusts for the environment or the changing environments. And decision making matters because it is the foundation of autonomy. And by autonomy, I just mean that the skill of taking decisions on its own. So it does not need anything called as a human supervision, or it does not need anything called as a overlooking. They'll just work on their own on basis of the input and on the basis of the goal. So the journey from getting an input to giving a meaningful output is what makes our agent autonomy. Yeah. And next, real world impact. How decision making really impacts the world. So whenever we talk about world, we are talking about the fast paced world where AI is growing day by day. So recently, a couple of days ago, I've just read a research article saying that almost 113 AI agents altogether have created a separate social media channel for them. So back when I was in my BTech in my first year, social media was a very new thing to me, and adapting to it was very hard for me. But when it comes to this time, where I just adapted to social media, an AI agent which was created yesterday it would have been created yesterday, or it would have been created some other week, a week ago or a month ago. It is more like a baby. But yeah, they are able to do something called as creating a separate social media channel where bots talk to each other. There's no humans over there. Agents talk to each other. Agent just communicates based on comments. So that is where we are right now. So we are nowhere far from a place called as autonomous or smart world. Autonomous or smart world. We are nowhere far. It is just near future. So this social media research article that I read is the life proof that sorry. So is the life proof that the world of AI is changing. So that's the real world impact that AI would be doing. So we have just talked about the future. Now we'll just talk about the present where these AI decisions or agent decisions are being taken. So traffic management. We all know that based on area, we'll have separate traffic cams. So if an area is less crowded, there will be a traffic cop who would be just controlling the whole traffic or who would be just controlling the traffic signals. He'll look at the road. If there's nothing, he'll let the way go. Or let's say, well, let us consider a new situation where the traffic is medium. So over there, there is something called as timed lights or timed signals, where for every 30 seconds or 60 seconds, regardless of what the traffic is there, or regardless of if there is any ambulance waiting over there, it does not matter in those cases. It will just stop the traffic or the bikes or cars for 30 seconds. It will let the other way go and then let this way go. So these are time things, but these don't need AI agents. The thing that needs AI agents is something that is being used right now, which is autonomous traffic detection. Let's say it is a heavy crowded area or a heavy traffic area. Let us just say we are in Bangalore. We are in Kormangla. We are in Bangalore. And it's the most, as we are talking, by the time it's almost 7. So by right on this time on Bangalore Kormangla Road, I'm pretty sure we have a traffic which would take 45 minutes, 30 to 45 minutes of time to clear. So in these cases, we use something called as optimal traffic management, where there is this agent that is monitoring everything, monitoring each and every piece of traffic right from the cameras that are installed in a traffic junction. And based on the traffic, let's say a lane has less traffic, it will just let the same lane go and stop the other lanes. Yeah. And it applies vice versa in the cases of emergency. So based on traffic, if there is heavy traffic, it would just let that lane go. If there is less traffic, they'll stop it and follow a protocol. So these protocols or these intelligence are not applied by humans. This is totally automated based on an agent called as optimal traffic management agent. Yeah. So this is a real world case where AI agents are used to manage traffic. Yeah. And another example is thermostats. So thermostats are general devices, as you people know, which help in maintaining temperature at a certain place or a certain room. So whenever there is this threshold temperature, let's say I put a temperature of 21 degrees and 21 degrees is the base. If the temperature goes below 21 degrees, thermostat says to the AC, saying ki, just put on put on heat mode where it turns the temperature mode, or just put on, if it's more than 21, just put on air condition where it cools the room. So these decisions are also not human. They are again automated or they are driven by an agent. So these two are simple if else. So these are simple if else conditions where if traffic is more, just let the lane go and stop the other ones. If the traffic is less, just stop it. If else. And smart thermostats is also an if else case, where if the temperature is this, do this, the temperature is that, do that. Yeah. But when it comes to navigation apps, it is not simple if else. Yeah. So it is not simple if else. It is prediction. When it comes to navigation is nothing but Google Maps again. So in Google Maps, we don't see, we see the data that is being relayed currently, which is being relayed currently based on the mobile's GPS. Let's say a bunch of mobiles are put together with GPS on in them. It'll just show that multiple devices are over there, which means there are multiple cars or bikes, and which in turn means that there is high traffic over there. Yeah. So this is again prediction based on the amount of GPS signals available over there and based on the movement of those GPS signals. If the movement is slow and there are multiple mobile phones with GPS on, we'll just see in the map a red color saying there is more traffic over here. If the speed is 20, 30, 40, between 20 and 40, it'll just say that it's orange over here where the traffic is minimal, but yeah, we still have traffic over there. So this is all prediction based on two or three factors. So this is not simple if else, but yeah, this is also a case where agents are used. So all these decisions of calculating the GPS or calculating the speed, and then based on the speed, calculating the amount of traffic over there is again done by something called as an agent. Yeah. So after this, we have autonomous vehicles. So autonomous vehicles is where the actual core part of self learning or self decision making AI agents get in. So we all know about Tesla. So we all talk about Tesla, but what is that one thing which made Tesla the best one out there? It's not EV, it's not their brand value, it's not Elon Musk or anyone. It's that one factor where they were producing autonomous driving vehicles, a vehicle which does not require a person to drive. So it drives on its own based on perceiving the environment. Based on the environment or based on the factors that are around it, it will just take a decision of either speeding or taking right or taking left. So these are the things that make Tesla the best one out there. Sorry. So these are the things that make Tesla the best autonomous driving vehicle producer out there. So how are they so good at it? They are so good at it because they have put multiple manpower, multiple hours of training their agents and making their decisions better. So in order to get a product of that sort, you need an agent. You need an agent which has human level perseverance. So we all just say each and every time when we teach something like AI, we just say that strong AI does not exist. Yeah. So strong AI is an AI which has human level thinking or human level perceiveness. So autonomous vehicles are not far away from them. When they are able to just predict what's happening or what's coming, when they are able to see what's coming and react to it, what makes it different from humans? What makes it different from humans is that one ability of critical thinking. So let's say you're in a situation which means you just want to get out of that situation. Your Tesla car won't take you out of the situation until unless it has all the factors saying the traffic is less, I can just speed away, or there are no objects right before me, I can just speed away. But if the situations demand, we need to go faster or we need to do something that is not conventional for an AI agent. So that is what is making a difference between us humans and the autonomous driving vehicle agents. So these are few real world examples where AI agents are in action right now. And the common thing that they have is they sense environment and they perceive information, choosing optimal actions. Uh, I hope we are clear till here. So if you are clear till here, we'll just move to this topic called as what is an AI agent. So the formal definition of what is an AI agent is, sorry, an entity that perceives its environment through sensors and acts upon it through actuators. So again, we'll just consider Tesla as an example. What does Tesla perceive? Tesla perceives something called as ultrasonic waves. The inputs that it takes are ultrasonic waves. So it just sends ultrasonic waves all around the car to see if there are any cars or if there are any moving vehicles, objects right in its radius. Let's say its radius is somewhere around 2 meters. It just sees if there is any vehicle in those 2 meters and if it's safe to go there or not. So it perceives out of sensors and acts upon its actuators. So the actuators of a Tesla car are generally the accelerator, which lets the car move front or back. So they are autonomous, firstly, which means they act independently without direct human control. An AI agent is autonomous and they don't really need human intervention. And again, they are goal oriented. And as the example says, they react to the environment and they make their own decisions. This is what an AI agent is. So you were just briefed what an AI agent is yesterday, and I just brought it up today because in order to understand how AI agents make decisions, we need to just clear the part where what an AI agent is. So I won't take a lot of time on this. We'll move to the next one. So the next one is agent environment interaction. We can just see a flowchart over there saying environment, sensors, perception, decision making, and action. So that's just the flowchart of things that we just talked about. So we'll just have a look on it. From where the decisions are being made, or from where the chain of command goes. So from environment, the data goes into sensors, saying
And from
environment,
sensors.
sensors, they either go to perception or they go to state representation. So after perception and state representation, we move to a part where AI takes decisions based on the perception or based on the decision that it is going to take. Next, after the decision is made or after the plan is done, we move to something called as action. So this thing is a continuous loop. Yeah. So this is a continuous loop where agent does not take a break. It just does its task as long as it reaches the goal. So the end goal of an AI agent would be the input or the task that the human gave him. So for a Tesla car, getting an end goal is getting to the house of the owner or getting to the destination where it is supposed to go. As long as it does not reach the destination, it does not stop doing all these things. It does not stop perceiving the environment. It does not stop taking decisions. It does not stop the action. So that's how an AI agent would work in a cycle until unless it reaches its goal. So these are few technical words where AI agent perceives, plans, decides, and acts. So we have talked about these four: perceiving, planning, deciding, and acting. But we did not talk about something called as learning. So learning is a concept where the agents have worked a lot on. So let's say an AI agent has reached a dead end where it could not find the required output. It did not reach its goal over there. So what happens? So it will just go back. It will just backtrack its each and every decision. It will just see at what point of time did I go wrong? At what decision did I reach to this goal which is not desirable? So it learns from those patterns, and next time, whenever there is a similar question. It makes sure that it does not go to the part where it has reached the dead end, but take the other way and try to achieve its goal. So that's how a perception, planning, and action cycle of an agentic AI goes. Are we clear with this? So we generally call it four-step process. But yeah, learning is the core thing which does not gets mentioned. But yeah, it is very important for you people or for the agent. So these are few examples of simple agents out there. So thermostat is a simple agent that that is being used by a lot of people out there, and a chess program. So if there are any chess enthusiasts in this FDP, they would be knowing that we have chessboards out there which can even beat grandmasters. Yeah. So grandmasters, they can also beat grandmasters based on the chess games that they have played in. Let us say I'll make a chess program based on Gukesh Dumaraju's games. My agent will just capture each and every mistake he has done in all the games and will make sure to play the counter rules which he can't counter. So that's how an AI agent based on chess program would work. It will just read or learn about his opponent and then work or act based on the incompetence that he has. So that's how chess programs or chess-based agents work. And a vacuum robot. A vacuum robot is a very important or interesting topic. So a vacuum robot is not a big robot like some humanoid robot. It's just a vacuum that just roams around the house. It does not go out of the house, or neither does it just go and hit few other objects. It will just perceive. It will just perceive things that are around it. It can't go out of the room if the room is closed. So for it, that room is a sandbox environment. And whenever it cleans or whenever it does its work, it will just move in a certain pattern to cover each and every inch of the room. So to cover each and every inch of the room, that vacuum robot will just start moving here and there first. Will just start moving here and there and then perceive. If it's a 4x4 room with two doors and three windows, those two doors are closed. So firstly, it might go to either of the doors and just see if either one of the doors is open. Uh, uh, do you have any questions? Okay. So we'll get back to the robot where it just perceives the whole room, and based on the room size, it will just make its own pattern on what to do at what place. So that's how vacuum robots work. So they are the prime examples of robots working in a sandbox environment or an environment that does not include outside world rather than the environment that they are in. A vacuum robot does not dare to go outside because its sandbox or its perceiveness is inside the room. It does not go outside as long as the doors are not open. So that's how AI agents work. They work in their environment based on the environment or the based on things or the resources that they perceive. So we'll get to the main part of the class, which is basic decision making approaches. So we have three decision making approaches. One is rule based, and second one is goal based, and third one is utility based. So we'll just talk about each and everything in an elaborated way. So in rule based decision making, we have something called as if or then loops. So if or then loops are cases where if a condition happens, what to do. So let's say we have a situation where you'll either have to publish one paper a year or two papers a year. So if you publish one paper in a year, you'll have 2-star rating on your name. But if you publish two papers in a year, you'll have 5-star rating on your name. So if one, then two, if two, then five. So based on these, our agent will start working, or our agent will start thinking to get the best outcome out of it. So if it's one paper, you'll get 2 rewards. And if it's two papers, you get 5 rewards. Based on the reward, even though the process might take some time, but because the reward is high, so our agent prefers the high rewarding part. So these agents are very simple and they are easy to understand. They are only based on if and then rules. And their logic is, or decision logic is very transparent. If this situation happens, that is the thing that you will be doing. If and then. This is how this goes. But when we talked about a situation where we had two constraints, paper one and paper two. Yeah. So let us consider there comes one more clause where you can either publish one or two and or three. And our agent is only made for two decisions. If two, if one, then two, if two, then five. One, two, two, five. You are getting a new constraint called as three. So for the third constraint, our agent is not ready. And you can't really make an if then agent with more than two constraints. Yep. So for those things, you'll have to adapt to a something different thing, a something or a some different rule. So if then rule based decisions are inflexible to change. They cannot handle uncertainties, where uncertainties are the cases where things don't go as planned. Even though you publish two papers, you don't get 5 rewards. There is some error which by which you don't get 5 rewards. Your agent can't handle those things. It won't learn from those things. It will just stop functioning or it will just get mad. So in those cases, you can't use if then rules. And it is difficult to scale. It is difficult to scale because there can be multiple, there can be multiple if thens. If this, then this. If this, then this. There could be multiple these things, and the loop could go non-stop. And the loop could go non-stop, which is not scalable. So with that, in order to perceive all of this, you need to have expert knowledge in agentic AIs to explicitly write and then optimized agent. In order to write an optimized if then agent, you need to have explicit knowledge on these things. So we don't generally prefer if then rules in cases where there would be some change. And what are the things that we'll be choosing? If not, if then what? In those cases, we have something called as goal-based agents. So goal-based agents act to achieve predefined goals. So by predefined goals, I mean the input that the user gives. So no matter what the situation is, no matter what the route is, our agent makes sure that it just reaches its goal. So but in order to reach its goal, it has 3 steps. Firstly, the step number one is goal formulation. So by goal formulation or in goal formulation, there is this concept called as defining what we want to achieve or understanding what the goal is. So our AI agent would just try to understand what is happening inside or what is that one thing that the user wants. So considering the previous example, the user wants 5 rewards. No matter what, he wants 5 rewards, but he does not want to take the second route or publishing two papers. So our goal-based agent would do something by hook or crook. It will just formulate some other way to get those 5 rewards in some other way. So it will just make sure that you reach that goal no matter what. And action evaluation. So by action evaluation, I mean the actions or the tasks that agent would be performing as steps towards reaching the goal. Yes. So action evaluation assesses with actions to lead the goal. So those are the steps of actions that would lead that agent to the goal. And decision process. Decision process is taken literally based on goal. So it does not deviate from the goal. So our agent does not deviate from the goal of getting the rewards. It does not deviate from the goal of getting the rewards no matter what. It does not just think about some other topic until unless it reaches the goal of getting 5 rewards. So few examples of chess goal-based agents are chess program. So a chess program would always try to checkmate you. A chess program would always try to checkmate you. Its goal is either winning or losing. So 99.9% a chess program would try to checkmate you or win on you. And another example is navigation. So the whole sole part of navigation is to reach the destination. And by destination, our agent will perceive it as the goal. No matter which route you take, no matter which way you take, you will somehow reach your goal or you will somehow reach a destination based on the map or based on the city or based on things that are around you or based on the streets that are around you. So this is how goal-based agents work. They formulate, they evaluate, and then they process. Yeah. And next, our next topic is utility-based agents. So by utility-based agents, I mean agents which measure numerical values, agents which measure numerical values of happiness, satisfaction, or preference. So it is very similar to the feedback that any supermarket would take or any product would take. So based on the feedback, the agent acts. So let's say utility-based agents would ask, sorry. So utility-based agents would ask the user's input. They would ask if the user wants to go left or right. So based on the user's input or based on the user's previous inputs, it does not ask input for each and everything. So if an agent asks for input, it does not make it an agent. If there is any human intervention in it, it does not make it an agent. So what it does, it acts on the previous or it acts on the metrics that it has been defined on. So let's say I say my agent, whenever you have a situation of taking left or right, prefer right. Even though it's wrong, prefer right. So my agent will reach to a point where it has to take a left or right decision. So it will try to prefer right and then go to the goal no matter what, taking the right way, not the left or the wrong way. So the decision selection is expected based on the utility and the trade-off handling. So the trade-off handling is to make sure the goals don't conflict on the decisions. So the end goal will somehow be reached. And you have something called as maximization principle in these cases. So based on the utility, agents choose actions. Agents choose actions that maximize expected utility. So this is the principle that utility agents generally follow. Are we clear till here? So do I have any questions till here? Or shall I just move on? Assuming that silence means that I have to move on and you people just perceived everything that I just explained, we'll get to something called as decision trees. So decision trees is a topic that we generally deal in academics. So we all teach decision trees to the students. So what is the purpose of decision trees in agents? We'll just get to know what is the whole sole purpose of decision trees in agents, AI agents. So a hierarchical structure used for making decisions through the sequential splitting of data is what decision trees model works, or is what decision trees model look like. And we'll get to know what the hierarchical structure is. So the hierarchical structure firstly starts with root node or the start node, the root node or the start node. And based on the root node or the start node, the decision nodes go. So it is again it is again very simple like an if else. So you take an input. Let's say the input is one. And in the condition node or in the decision node, you put a decision or you put a condition saying if it is one, take left. If it is zero, take right. So based on the input or based on the root node's input, the decision nodes change. Yes, if it is one, take left. If it is zero, take right. So after taking right, what happens? The output that we take resides in something called as leaf nodes. So this is the hierarchical structure of decision trees in AI agents. And what are the key characteristics of decision trees in AI agents? We have a concept called as sequential splitting. So the data is split based on features at each node. So on each node, the data is split for, for a reason. The data is split for a reason where the reason lies in the input or the prompt that you're given. So the sequential splitting literally depends on the input and the prompt. Yep. If you're clear with this, we'll just move. Yeah. This is the hierarchy that we just talked about. So root node, node, and a leaf node, where the values I've taken an example of probability value and I've taken an example of condition value. And in the picture, we have an example of probability value. So this is the literal visual representation. So our next topic is why decision trees are explainable. We'll get to this, but yeah, before that, I want you people to just pick a pen and paper if it's right beside you and make a decision tree on your own example. Take an own example and make a decision tree for an AI agent. So consider all these things that we just talked about and just make a simple decision tree where you let the agent decide or you just form the conditions on which the agent should be working on. So we'll just take a couple of minutes and make the decision tree. I'll just make it right with you. Yep.
ఉన్నాను మేడం ఇక్కడ ఇప్పుడే
So I hope we are done with drawing it.
hello Harsha
Yeah,
sir,
ma'am. Yeah, ma'am.
are you there sir? Yeah, it was actually we are thinking what happened to the whether it's a problem with the meeting or what, so I'm just calling you.
It's not a problem, ma'am. I just we just talked about decision trees, and I just asked each and everyone to just write or draw a decision tree on their own. So we
Yeah,
are just
okay sir.
taking a couple of minutes to draw
Okay,
them.
okay sir.
Nothing
So
much.
when I saw it was actually it was on hold, so I'm thinking whether it was a problem with the Teams.
No, ma'am.
Sorry to disturb
That's
you,
not a
sir.
problem. No, ma'am.
Yeah,
That's
sir.
not a problem.
Please continue.
Yeah. So we'll just get back to discussing what we were discussing. So the thing that we were discussing is decision trees. So I hope you people have just drawn. I hope I've drawn an example on my iPad where the example says if if it rains, just take an umbrella with you. If it does not, don't take an umbrella with you. So that is the condition that I have taken. So that is the condition that I have taken. So can I just can you just people can you people just write in the chat what are the conditions that you people have just considered in making your own decision tree? Yeah, that's the chat again. So if we are done with, if we are clear with the decision trees, we'll just move on to, yeah, I'll just wait for 1 more minute and see if the chat pops up with any examples that are better than mine. They'll be way better than mine, but yeah, I'll just wait. So previously we were just done with these things: rule-based decision making, goal-based decision making, utility-based decision making. We are now at decision trees, and the tree structure is also done. So we'll just get to the point where is my screen visible? Is my screen visible?
Yes, sir.
Yeah. Thank you, ma'am. So I'll just move to the part where why decision trees are explainable or why they are better. So decision trees just show you a very clear path, a very clear path of why you got that output. Let's say I took that umbrella outside. That decision tree will just show me the clear path. Key, why did I take that umbrella out? Because it was raining. And the logic that are in decision trees are very human readable. Right when you see through your naked eye, you can just make out the logic. And each and every decision or each and every node that we choose are retraceable or backtrackable. We can just get back to the previous versions and just recheck the condition. Keep why did my agent take this or why did the condition reach to this point? So this is why we call decision trees as step-by-step traceable. And we have something called as regulatory compliance, where decision trees meets all the requirements for an explainable AI. So this is a new word, explainable AI. So we'll talk about what explainable AI is. I'm pretty sure each and every one of you would have heard something called as explainable AI. So an explainable AI is a type of artificial intelligence that can that can just reason itself, that can just reason itself, saying why has it taken that decision. So it will just reason. If let's say ChatGPT has given you an answer or some AI agent has given you some answer, whenever you ask something saying, why did you give me this answer? Why did you give me this answer? That AI agent is able to explain or just backtrack or is able to just backtrack to the reasons why it has chosen that path or why it has given you that certain output. So this type of AI agents are known as explainable AI agents, where it can just reason or it can just give you static paths of routes of how it has just reached this point. So these type of AI agents are known as explainable AI agents. So we'll just get to know what are the real world decision tree examples. So the real world decision tree examples are medical diagnosis. So medical diagnosis, we generally diagnose medicines based on symptoms. If you have cough and cold, you take some certain tablet. If you have something and something, you do this thing. So that's how medical diagnosis is done. So the core part of medical diagnosis is again decision trees. And next, credit scoring. So credit scoring is a complex topic, but yeah, it's more like a complex algorithm, but still to the core part of its logic, it is again a simple decision tree. It might seem big when it involves something called as banks, or it involves something called as income history, or something like your CIBIL score, all these things. But yeah, when it comes to the core logic, it is a simple decision tree of deciding whether to let you to take that loan or opt that loan, or whether to not let you to opt that loan. So it just decides if you are eligible of getting that loan, or if you are not eligible of getting that loan. So it is again a simple decision tree. And same goes for fraud detection and customer segmentation. Fraud detection detects patterns. If those previous patterns just match, it will just say that this is fraud. If it does not match, it will just say that this is not fraud. So that's how fraud detection works. And customer segmentation. So customer segmentation is very simple. Based on customers' previous decision. Let's say whenever I go to some market or some shop, I buy everything that I see or everything that I like. So based on my own liking or based on my own decisions, if I like that, I'll take it. If I don't like that, I don't take it. It's that simple. Customers are segmented based on the way they buy or the way they think. And this again helps in something called as market segmentation. So these are few real world examples of decision trees. So our next topic is planning and search. So so far we have discussed single decisions, right? We have just discussed
Hello, sir. Hello, Harsha, sir. Yes, sir, please. Respected participants, sir got a technical issue. He'll be joining us soon. Please wait. Thank you, everyone.
Okay. Am I audible?
Yes, sir, you are
Yes,
audible,
sir.
sir. You can share your
Yeah.
screen, sir. Yeah.
Thank
Meanwhile,
you.
I'm sharing the feedback form for today. Please, all of you take some time for filling the feedback form. Thank you.
So if my screen visible, if my screen is visible, we'll just resume the class or we'll just resume the
Yes, sir.
session.
It is visible, sir. Yes, it is visible, sir.
Sure, ma'am. Thank you. So yeah. So we'll just resume. So far, we have discussed single decisions. Yeah, we have just discussed about single decisions. But many real problems require sequence of decisions or multiple decisions working all together. So planning. Planning is a concept. Planning is a concept which is about choosing a series of actions to achieve a certain goal. So you plan something to achieve a certain goal. So for example, so let's say my goal is to reach to a classroom. So I'll just stand up from wherever I'm sitting and start walking towards the door. Yeah, I start walking towards the class door and open the door. And then I enter the room. So these are the plan, these are the plans that I make right before I stand up. So if these plans are successful, I just reach my goal of going into the classroom. So planning assumes planning assumes the agent can predict the outcome of its actions. So right before it acts on the plan, it will just assume that it can just reach to the goal. So agent thinks or plans very similar to how we do. So search strategies and heuristics. So we'll just get to this part. So such techniques help the agent to explore all the possible paths. So there are few search techniques which help help the agent in order to either fastly reach the goal or somehow slowly reach the goal. So these are two metrics. One, reach the goal ASAP or as soon as possible. So in order to do that, we just numb we just numb out few decisions where we don't recheck the output that comes in. So I so there's this agent called as Gemini Flash 3.0 or Gemini Flash is the agent that recently Google has just released. So it is an example of faster retrieval or faster search. It gives answers faster than Gemini 2.5 or Gemini Thinking or Gemini 2.5 Pro. So all the other agents or all the other models, they just consider they just reconsider the answer right before they give you an output. But Flash does not do that. Flash will just give you the first answer that it has retrieved from the database. So it is your choice whether you need an accurate answer or or you need a faster answer? Or do you need to reach your goal fast, or do you need to reach your goal slow with all the checks done? So if if you want to get all the checks done, we have something called as focus exploration. Yeah. So the focus exploration goes like direct search towards promising areas of state space. So when it comes to focus exploration, the database or the knowledge base of any AI agent is vast. It is very big. So whenever you give an input or you ask a question, the agent does not just go through all the parameters. It has some billions of parameters. So in order to give you an answer out of those billions of parameters, it would take it years, not years, centuries, in order to give one answer. But AI agents don't work like that. So they don't really take centuries to give you an answer. At some point, they will just take nanoseconds or milliseconds to answer a question. How do they do that? They all do that through a concept called as focus exploration. They don't go through all the parameters. They just go through parameters which are related to the question. When I ask the agent regarding a recipe for some curry, it does not go and search for machine learning models, or it does not go and search for some chemicals. It will just search for the recipes and then give me the best recipe out of it. So that's how focus exploration works. And practical intuition. So practical intuition is another metric where it considers experience and domain knowledge. It considers experience based on the previous searches and the domain knowledge or the base knowledge it has to guide decisions. So decisions could be as simple as going going to a shop or going to a certain table in its database to get. So they could be as simple as getting a yes or no answer or getting a research thesis. Both of them are done based on practical intuition. So we are just done with planning and search concepts. Planning, how does an AI plan, or how does an AI agent plan, and how does an AI agent search? So we are done with the part. And next, the next part is reinforcement learning. So we won't be learning how reinforcement. I mean, I won't be teaching you people the syntax or the whole thing how reinforcement learning works. That's not very useful in cases where we are considering AI agents. We don't really hard code AI agents. AI agents are either low coded or no coded. So they are either low coded or no coded. So we'll be discussing about low code or no code agents in the fourth day, or yeah, on the fourth day. We'll just learn how those low code or no code agents are built. So firstly, we'll consider how reinforcement learning acts only based on intuition. Yeah. So AI agents or reinforcement learning briefly touch upon sorry, I just confused. Yeah. So let us just consider an example where a child touches a hot object. Yep. A child touches a hot object and feels the pain. He touches a hot object, feels the pain. He does not go and touch the same hot object again. Does he? He does not do it. He just avoids touching it the next time he sees that hot object. So reinforcement learning is inspired by how humans and animals learn. Yeah, it is literally inspired by our own thinking. And you have something called as an RL loop over here. The reinforcement learning loop, we have five core components. We have five core components. One is agent. One is agent. Another one is environment, agent, environment, action, reward, and policy. We have five: agent, environment, action, reward, and policy. So we'll just see how or why do we have all of these. The agent is not told what to do. Yeah, make this clear. The agent is not told what to do. It learns by trial and error. It learns by trial and error, and it is guided by rewards. So whenever it does a trial and it succeeds, whenever it does a trial and it succeeds, it gets few rewards. It gets few rewards. And over time, the agent learns an optimal decision strategy based on the rewards that it is getting. It will just make up its own decision strategy, which will make sure that it does not go into an error part, but end up in a part which gives them the actual output that they need. So that is what the core feedback form or the loop form of reinforcement learning is. Agent acts based upon the environment and then performs actions, and based on actions, if the action leads to the correct path, it will just be rewarded. And based on the reward, if there is a reward, it is good, or that action is correct. If there is no reward, that action is wrong, and we avoid taking that action the next time. So the key difference is reinforcement learning learns from outcomes. It does not learn from predefined rules. So whenever we talk about RL, it is always it is always about learning, not predefined rules. You don't put rules to RL. You don't put rules to an RL agent. It just learns things on its own. So you have few differences over here. So the first difference is deterministic outputs. So the outputs are determined or predefined. Whenever there is an output, it is just predefined or predicted before it is given and requires expert knowledge. So in order to write those rules, in order to write down those rules, you need expert knowledge on what the input would be or what the output would be. But in the case of reinforcement learning, you don't need them. The agent learns on its own. It takes in the input and tries to get an output. It will just try and try and try unless it gets the best output. And these predefined rules are inflexible to change. So you just plant a rule and you can't change the rule. But when it comes to reinforcement learning, those rules are they don't exist. There only exists something called as a reward based system or a feedback loop. So that feedback loop continues as long as the process exists. As long as the process exists, the feedback loop continues. And the more feedbacks you get over time, your loop becomes better. Yes. So there is only one. You only have one point that makes it a bit hard, which is this. Which is this. The last point. The last point is all this requires something called as training data, or all this requires something called as time, which this time is taken by the reinforcement agent to learn based on its mistakes. To learn based on its mistakes. So combining rule-based systems with learning-based approaches is what gets you hybrid AI solutions. So you can't go without rules, neither can you go without learning-based approaches. So somehow essentially getting both of them together would give you hybrid AI solutions. Yeah. So if you are good with this, if you are good with reinforcement learning, if you are done with this, we'll move to the real world applications or the places where AI decision making is in practice, is in actual practice. So decision making in IoT. So there's this concept called as edge computing. So edge computing is a concept where you have sensors. You have sensors and microcontroller units like Raspberry Pi or some other advanced MCUs or MPUs, which which hosts all these models, in an environment. Let us just consider the house that we have on the left. And all of these lighting control, smartphone alerts, energy management, alarm control, temperature control, these are few smart devices that are inside the house. All of them, all of them are managed by something called as an edge computing device. So this edge computing device manages all the decisions that are made locally. It manages all the decisions that are made locally on the devices. And the decisions that this edge computing device or this edge based AI agent takes are immediate or real time decisions. It does not have predefined things. So, keyless entry, let's say keyless entry. A keyless entry will only be activated whenever there is an NFID tag or an RFID tag which matches its encryption. It does not open on its own. But yeah, it comes in place where there is some RFID tag, NFID tag, or there is this what do you call facial biometric sort of thing. So these are few local features or real-time decisions that the edge computing agent would be taking. And we have something called as optimized for low power and memory. So whenever you start considering all these things, you get advantages. You get advantages where these advantages will lead you to using limited resources. So lighting control is an example for that. So lighting control, whenever a person enters into a room, light gets switched on. So it is a very simple one. If a person is there, switch on a light. If no, switch off a light. This saves a whole lot of energy than we consider. So if it's a small room, that's fine. It's just a simple bulb. But yeah, if it's a two-story building and there are 7 lights per room, it's a very hefty money-based job. So in order to limit these resources, we can just apt to something called as edge computing based smart homes. Yeah. So by this, you'll have to understand that there is one loop going on. One loop going on. That loop is sensors help in making decisions. Sensors help in making decisions, and these decisions are again helping in taking in action loops. Okay, these sensors are again helping in taking in action loops. Are we clear with this? So this is another example of smart cities and traffic management that we just talked about in the starting of the class. So real-time signal controlling, route optimization, pattern recognition, these are the things that I just briefed in the start of the class. And next, energy and industrial applications. So where do AI agents help in energy and industrial applications is demand response. So demand response. What is demand response, or what do agents really do in demand response? We'll just get to know what do they really do. So they help in balancing energy. They help in balancing energy and also reducing energy consumption. Yeah, they balance energy and also reduce energy consumption in real time. So which again helps the industries to somehow scale their budgets less. And next, load balancing. Load balancing is a concept where let's say there's this motor which is built so that it takes in 2 hours of load. So instead of giving it 2 hours of continuous load, our AI agent would take a decision of giving load for every 10 minutes and load for every 20 minutes and break for every 5 minutes. Load for every 20 minutes and break for every 5 minutes. By this decision, our AI agent would get the motor working for twice the time than it generally works. Let's say if the motor is working for 2 hours a day and it just gets switched off because it gets overheated. What our agent does is it somehow balances the load so that the motor keeps running for 4 hours, not continuously, obviously. It won't run continuously, but yeah, it will just clock a time of 4 hours in the entire day instead of 2 hours. So if you want a better output, you can choose it. But if it's a continuous output, it won't be useful. By this, we have we have an advantage of renewable integration. So renewable integration, what do I mean by renewable integration? So we all know about renewable energies that can be replenished. So AI agents would also help you in getting or making these things better in order to just schedule when to switch on solar panels or when to take more power based on the temperature, and when you consider windmills, so when to put on the windmill in this direction based on the weather data. So these are the decisions that applications or industrial applications use AI agents in. So, and automation. Automation, we have general points like what? Predictive maintenance. The maintenance is predicted. Let's say if a motor is to be depreciated on the 20th day of this month, our AI agent just notifies us on the fifth day, saying on the 20th day, this motor, this X motor is going to depreciate. Somehow just repair it so that you won't be halting your work on the 20th day. So this is an example of predictive maintenance. So quality control. Quality control is where we humans make a lot of mistakes. Not a lot, but yeah, we do make mistakes. But AI does not. AI does not make mistakes when it learns from patterns like reinforcement learning, or when it learns from things like rule-based learning. So these patterns or these predefined rules makes AI with less error rate, and hence making sure you deliver good quality out of it. And when you consider all of this together, all of these in a single box, you get something called as production efficiency. The product that you'll be delivering will be more efficient than it was before. So this is how AI agents would help in industrial applications. Yeah. So we are technically done with how AI agents make decisions. And after AI agents making decisions, what is the real world impact that those agents would be doing? Yeah. So this is how things works when it involves agents and when it involves decisions taken by agents. Yeah. And that's the end of the session. Do you have any questions? Do you have any questions regarding the session? Or do you have any questions regarding the topic? We'll take the next 5 minutes for answering the questions that you people have.
Good evening, everyone. If you have any queries, sir is here. You can ask him. We are at the end of the session.
Thank you, sir. So, and also, I just forgot to thank you people to give your time and put this much effort to just listen to what I was about to say or what I said. And I hope I made a difference. So, what are the approaches? What are the new approaches in decision making? So, the new approaches in decision making. So, it depends. It depends on things like, sorry, it depends, ma'am. So, it depends on the input. Let's say the approach. For example, I'll just explain it based on an example. My camera is not opening. Okay, fine. So we'll just stick to the approaches of decision making. The approaches are based on the input. If the input needs 100% accuracy, if the input needs 100% accuracy, the approach is not rule based. It is goal based. So somehow you reach to 100%. So there will be by hook or crook or by some case, you'll get to the decision or you'll get to that goal by making decisions like what? Yes or no, or taking left or right, or choosing a certain journal or taking this journal. So these are the things that makes a difference in decision making. I hope I answered your question. If not, you can just ask the question again or ask it in a different way.
Sir, good evening,
Yeah,
sir.
sir. Good evening, sir.
This is Jagdish from KL University.
Yeah, sir. Go on.
It's a great session on
Thank you, sir.
AI agentic, but I have one information required. So
Go
present
on, sir.
scenarios, IoT also be major environment, major scenarios. How
Yes, sir.
IoTs are whenever the data is collected through the IoT,
Yes.
where is the agentic AI fit in the process?
So agentic AI fits in the process where you put an edge device. You put an edge device like a device that is able to process the model. The device that is able to process the model of an agent. So the real-time data gets into the edge device, for example, a Raspberry Pi. In the smart automation case, the sensors take in the data and give it to something called as a Raspberry Pi. So that's the edge device that hosts the model or that hosts the agent. So that's where our agent fits in. It fits in the edge device or the computing device. It does not fit in some cloud thing. It just fits in the edge device or the microcontroller unit that we have in each and every house or that we have in each and every system.
Um, Sir, actually, the point is I'm teaching the one subject called Foundations of AI-enabled edge computing.
Okay, sir.
AI-enabled edge computing, where the, the most of the data is containing the large features,
Yeah, sir.
large number of features.
Okay.
So when I use the PC algorithm, principal component analysis for
Okay.
edge computing,
Yeah, sir.
so PCA process the, for example, the health data, medical analysis data, for example, brain cancer diseases. So for example, the
Yeah.
PCA analysis, PCA, the brain analysis data, it contains a lot of information. But how the edge computing, uh, while processing the AI information, there is a optimization techniques are required now, sir.
Yes,
So
sir.
the
It does
AI
require
agentic
optimization.
provides, yes, sir, that's the reason. Agentic AI also supports the optimization.
Yes, sir. It does.
Yeah. Right, sir. Thank you.
Yes. So do you have any more questions or did I just miss any chat of questions? I did not. Thank you everyone who just thanked me. I just thank you people for putting in the effort of attending this out of your free time and putting in the effort to learn or adapt to the new technology that is out there. Making sure all of your students or all of your people around you are updated. So this is a great effort put by each and every faculty that's over here. Thank you to everyone who's here.
Thank you so much, sir. Harsha, sir. You have
Yeah, ma'am.
explained how agents make decisions really well and about the basic decision making steps and simple planning methods and search techniques and utility and goal based reasoning. And your way of explaining with the examples really helped a lot. And you have cleared the doubts also. Thank you so much for your nice presentation. We are very lucky to have you here. And let's hope that we are going to meet very soon in another important sessions.
Sure, ma'am. Thank you.
Thank you very much, sir, for your valuable time.
Yeah.
So this is the end of the session. Thank you, everyone. This is the end of the day 2. I hope everyone filled the feedback form. So we are not going, as we have discussed in the last day, the feedback link will not be shared in the WhatsApp group. You have to fill it by only taking it from this YouTube channel or from the chat here. Thank you for your valuable time. Let us meet tomorrow again at the same time at 6:30. Sure. Thank you very much.
Ma'am.
Thank you, sir.